Today we are going to look over the next two ways to prove that triangles are congruent, and both of them use the same pieces but in a different order. Last time we talked about the first two, side, 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 and side, angle, side. Now we're going to look at ASA and AAS. So let's go ahead and jump in. The first one, ASA, stands for angle, side, angle. So that's ASA. All right, and notice in our words, side is in the middle. So for this one, we'll have two angles and the side that is between the angles. B/T stands for between. So if we've got triangle QRS and triangle, oh, that's horrible, TUV. If we know that Q and T are congruent, and we know that, say, R and U are congruent, the side that connects those two angles, that's QR and TU. So if we know those sides are congruent, then that gives us enough information to say that triangle QRS is congruent to triangle TUV by angle, side, angle. Again, it's two angles and the side that connects those two angles. Our fourth method is angle, angle, side, and we abbreviate that AAS. And it's very similar, except our side is not between. So side is not between the angles. And that's why it comes at the end of the name. So if we have GHI and JKL. So if we know G and J are congruent, and we know H and K are congruent. Now in this case, there's actually two possibilities that we could have to use AAS. We could have HI and KL are congruent, or we could have GI and JL. We don't need both of them. We could have either of them. So we've got the purple or the orange marks. And it's kind of hard to tell the difference between the orange and the red. So sorry about that. But by having that, either of those methods would show us that triangle GHI is congruent to triangle JKL by the angle, angle, side method. So let's practice a few of these. We'll We'll determine if these are congruent and what method would show us that. So for 1A, here we've got this pair of angles. We've got this perpendicular box down here. Remember, that's a right angle. But if that's a right angle, this is a right angle. And remember, right angles are always congruent. So we know those two angles are congruent. And then we've got these sides here where I've circled in green. So we've got two angles and a side. We know they're congruent. The question is it side, angle, side? Excuse me, is it angle, side, angle, or is it angle, angle, side? Well, the congruent sides connect our angles, so that will be angle, side, angle. It's all about where that side is. For B, we've got those congruent angles. Again, because we've got that perpendicular box, we know that the one next to it's also a right angle. And they share a side, so we know that side is congruent to itself. So here we've got two pairs of angles and a pair of sides, but the side does not connect our angles. The red and blue angles are not connected by the sides that are congruent, And so that means it's AAS. For C, we've got this pair of angles, okay, the ones that are marked. We've got some vertical angles that are congruent. We use 2 marks because they aren't the same as the ones circled in red, but they are congruent to each other. And then we've got our pair of congruent sides. Our sides do connect the angles, so that will be angle, side, angle. For D, we've got a pair of angles there. We've got this pair of angles. The 2 triangles share a side. That side does not connect our 2 angles, so that will be AAS. For E, we've got this pair of angles. We've got this pair of angles up here, and we've got some vertical angles. Okay, so we've got 3 pairs of angles. Is AAA one of our options? No, it is not. So we do not have enough information. When you are trying to prove congruent triangles, you always have to have a side. And this one doesn't give us any sides. For F, we've got those angles, we've got these angles. The triangles are put together, but then one of them's flipped upside down. And they do share a side. And that side does connect the red and the blue angle. So that means it's in the middle, so that's ASA. For G, we've got a pair of angles, we've got 1 pair of sides, and we've got another pair of sides. Well, the only option we've had that has 2 sides and an angle was SAS. But is our angle between our sides? It is not. We would need it to be this angle and this angle. The purple angles are the ones it needs to be to use SAS. So that means we do not have enough information. Now H and I are really just like F. H is almost identical to it. The triangles are just stretched out a little bit. So that will be ASA. I is very similar. The only difference is it uses right angles instead of marking them as congruent. But as you know, right angles are congruent. So again, that one will be ASA. All right, now we'll walk through a couple proofs so we can use each of these in a proof just to see how it works. Let's go ahead and write our given statements in. Angle G is congruent to angle M, and GF is parallel to HM. Our reason is given, and we want to go ahead and mark these in the picture. Remember, as soon as you say a congruence or a parallel or a perpendicular, anything like that in a proof, you want to draw it in your picture so your brain can process the picture better. So angle G and angle M are congruent, and we know that GF and HM are parallel. Remember, to say they're parallel, we can use arrows like that, or we could turn them into triangles and fill them in. Both of those would show these lines are parallel. Well, something that should pop out at you right off the bat is that they share a side. So let's go ahead and mark HF is congruent to itself. HF is congruent to HF. And anytime you have congruent to itself or equals itself, that is the reflexive property. Now, for our next step, we got to do something with these parallel lines. So it helps if you extend the parallel side so that you look like you have lines instead of just 2 line segments that are parallel. And then we'll extend that diagonal to make it look more like a transversal. So you can see here that we've got these 2 angles, the 2 with the green dots. Those are alternate interior angles, and you know that those angles should be congruent when the lines are parallel. So that's angle MHF and angle GFH. And the reason those are congruent is the alternate interior angle theorem. I'm going to go back and erase my green so you can see the thing a little bit better. Let's mark those congruent. So now you can see it a little bit better. So we have two angles and a side. And so our question is the side between the angles? Does it connect the two angles? It does not. And so that's how we know we're going to use AAS. So triangle HMF is congruent to triangle FGH. In our last proof, right off the bat, my triangles are named wrong. We want to prove triangle APC is congruent to triangle BPC because there is no HMF on this figure. Let's go ahead and write our given statements in. CP bisects angle ACB, and CP is perpendicular to AB, and our reason for that is given. So let's take the first part of our given statement, that CP bisects ACB. What does a bisector do? Remember, an angle bisector does the same thing a midpoint does. It divides an angle into two congruent angles. So those two angles are angles 1 and 2. They conveniently have numbers so that it's easier to write. But the reason for that is the definition of an angle bisector. Right off the bat, before we got through after we wrote step 1, we should have gone ahead and marked this as perpendicular. The fact that we didn't doesn't hurt anything, but we just didn't notice it. I didn't notice it. You might have. I like to go ahead and put the box on both of those to remind me that they are congruent. And so, but we need to say that in our proof. So all we're told is that the two line segments are perpendicular. What does perpendicular mean? It means that the angles are right angles. So we could say angle APC and angle BPC are right angles. And that's because of the definition of perpendicular. Perpendicular lines are lines that form right angles. And if they're both right angles, we know that they're congruent, because all right angles are congruent. Now, there's one other thing we haven't put in here that we need to, and if you look at the picture, you should see it. These two triangles share a side. They share CP. So CP is congruent to itself. In the picture, we just mark it, but in the proof, we actually need to make it a line. CP is congruent to CP, and that's the reflexive property, just like it was in the last problem. And you need to add one more line to this proof. And it's our, excuse me, it's actually our proof statement. Because once we get CP in there, we can look at our picture and say, hey, we have two pairs of angles and a side, and that side does connect our angles. So that's going to be angle, side, angle as our reason. So that's it for today. You now have learned 4 ways to prove triangles are congruent. You have SSS, SAS, ASA, and AAS. Next time we'll learn the last one, and we'll see what we can do with these congruent triangles once we've proven them. But before you get there, let's go ahead and do your practice work. Make sure you're asking questions. Get ready for that mastery check. Good luck.